we are going to discuss some important parts of matrices. That is nothing but inverse of a matrix. How we get inverse of a matrix? Would be thinking in your mind that inverse of a matrix, how we get it first of all. Then we get inverse of a matrix by two methods. The first one we have by elementary operations of a matrix, which we would be learning now in this video and next further videos of this course. But this one, second method, that is by formula, that is A inverse is equals to adjoint of A by mod A. Mod A is also read as det of A, that is determinant of A. This we will be getting to learn in our next course, that is determinant. So for this we need to go ahead and wait for it. So starting with this, my dear friends, for knowing this method we need to know some more things before it. That is nothing but the invertible matrices. What are invertible matrices? Invertible matrices means if A and B are two square matrices of same order M. If we have two matrices A and B and they are of same order M and they both are the square matrices, then they should be such that AB is equals to BA is equals to I. It means what, my friends? As I have said in my previous videos, that AB will not be equals to BA in multiplication of matrices. But mind you, my friends, if it's a square matrix, then there are chances of it to be possible that AB is equals to BA. And this condition also says here that AB should be equal to BA, and these both also should be equal to identity of this order. Same order M should have an identity, and that identity should be equal to product of both. So then matrix B is called the inverse of A, or it applies vice versa also. We can say even matrix A also as the inverse of matrix B. Then matrix A is said to be invertible. If following conditions are applied and they are satisfied, then we can call that matrix as an invertible matrix. So next in the line we have how it is denoted. A matrix, an invertible matrix, is denoted by A inverse. Since it is invertible, so we say them as A inverse, means A to the power minus 1. We write them as A to the power minus 1 and we say them as A inverse. So next in the line we have an example stating that same definition here, that is we should have what? First, A and B of two square matrices of same order. So we have A and B, two square matrices of same order, 2 by 2 and 2 by 2 here also. So what we get here, such that AB is equals to BA, means AB, first we find AB, here we get AB, this one is the AB, as an identity matrix we get AB. So if we try getting the BA also, then we will get this same here BA. So AB is equals to BA and that is equals to I. As the rule goes here, AB is equals to BA, that is also equals to I. So we can say B is the inverse of A, that is B is equals to A inverse. So now we have some important points which we should keep in our mind during solving these problems. That is, in the first we have a rectangular matrix does not possesses inverse matrix. Why? You must be thinking, why a rectangular matrix cannot possess a inverse matrix? Because products BA and AB to be defined equal and to be equal, it is necessary for A and B to be a square. Means to get the products A and B, AB and BA, and to be defined and to be equal, those products to be defined and to be equal, it is necessary for both the matrices A and B to be a square. If it is not a square, then this AB and BA will not be defined. So we cannot get the product in AB and BA. So rectangular matrix does not possess inverse matrix. The second rule says that if B is the inverse of A, then A is also inverse of B. Just the vice versa, as I have told you in the starting itself, that it applies vice versa also here. Then that same here also says that if B is inverse of A, then A is also inverse of B. So my friends, now we have some important theorems which are asked in exams. So the first theorem says here that uniqueness of inverse. Uniqueness means it's unique in its own. How? Inverse of a square matrix, if it exists, is unique. Means it says that if a square matrix has got its inverse, then that obtained inverse matrix is unique in its own. Means there will not be any other matrix as same as this, and applying the condition that that matrix is also a inverse matrix and a square also. So this satisfies the uniqueness of inverse. Next theorem says that if A and B are invertible matrices of same order, then AB whole to the power inverse is equals to B inverse A inverse. As the same had applied in the transpose problem, then AB whole to the power whole transpose is equals to B transpose into A transpose. That applies here also. AB whole to the power minus 1, that is AB inverse is equals to B inverse A inverse. Remember, this is very important point and it comes in MCQs, so we must remember it. AB whole inverse is equals to B inverse A inverse. Next we have elementary operations on matrices. Elementary operations, how we get elementary operations of matrices, that we will be getting to learn in our next video. Let me tell you, elementary operations are also called as transformations, and totally there are 6 elementary operations of matrix. In matrix we apply 6 types of elementary operations to get the inverse of a matrix, and out of those 6, 3 we have due to columns and remaining 3 we have due to rows. So with this, hoping that